Everyone, welcome back to the RBT Security YouTube channel. This is part 2 of our Kubernetes penetration testing series. In this video, we are picking up where we left off, compromising a container and now moving vertically to escape that container and take over the node using Docker socket abuse. If you are new here, please hit subscribe, drop a line, and let us know in the comments what adversity emulation content you would like to see next. Your support helps us keep building real-world, no-fluff content that empowers the offensive security community. So every click counts. We are operating inside the RBT Security Kubernetes lab. In part 1, we got a reverse shell on a container via command injection vulnerability. Now it's time to escalate, and let's move from the container to the working node. Before to do so, we need to gain our initial shell by exploiting the vulnerability that was identified in part 1. Once we have our reverse shell, the next step is to improve our reverse shell. There you go. We are starting from the compromised container shell. But before to continue, let's talk about what is docker sock file. This socket is a direct line to the Docker daemon. It lets us manage containers on the host. If this is mounted inside a pod, means that it's a major misconfiguration. An attacker can out the node. So in this video, we are going to show you how it can be abused to break up the container boundary. The next step will be download the Docker CLI. We can do it by using wget. Once it's downloaded, we just need to use the command tar. When all the files are decompressed, we just need to move inside of the folder. The second step is to check for Docker file if it's accessible. So we can do it by using the ls command and the curl command. The curl and the ls command output show that the Docker socket file is exposed. This means host level control. The next step is to escape out of the container. For this scenario, we are going to use read only mode. We launch a container with the host file system mounted at the RBT security folder. This read-only mount is useful for safe exploration. And as we can see, we are inside of the host file system. We can navigate inside of the root folder and retrieve and read all the files. In this scenario, we successfully move vertically from the container to the worker node. And we can corroborate that by showing that we have access to the same file in these new windows, the worker node windows. We successfully move vertically to the operation system. Omitting the argument RO giving us full write access. This is another way that we can do it. Here is what we have learned today. Docker sock file is dangerous when it's exposed. Mounting it gives attacker full Docker daemon control. From there, it's easy to escape containers and compromise the nodes. This is why runtime hardening and secure configuration are so critical in Kubernetes. In part 3, we will look at interacting with other pods, different vulnerabilities, server-side template injection vulnerability, exploiting the privilege flags, and even touching kernel space. Stick around, our Kubernetes adversary emulation is just getting started. Thank you for watching. Like and subscribe, and follow RBT Security for more adversary hacking content. See you in the next one.